All right, in this example, we also want to find the leading term and state the degree of the polynomial, but I have it in factored form. So if we want to find the leading term, we need to multiply it out. We need to expand it. But all we really care about is the leading term. We don't have to know all of the terms. So, you could expand this and, for example, I would probably, if I was going to expand this, which I don't want to if I don't have to, because it's always better to work smarter and not harder. so, so I would probably start with these last two binomials and multiply them out, right? I would get 4x squared, and then I'd just FOIL them out, right? So I'm going to get 20x minus 3x, so I would get that would be a plus 17x, and then I'd have a minus 15, right? And then I would have to take this next binomial and I'd have to distribute it across each one of these terms. Again, all I care about is the leading coefficient. So a tip is just to take the leading coefficients of each one of these factors and multiply them together, and also include this constant out front. All right, so the leading term of this function is going to be, we're going to hold on to that minus 2, and then it's going to be x to the 5th times 4x times x. Multiply that all together, and what you will get is the leading term. So we have minus 2 times 4 gives us a minus 8. X to the 5th times x gives us x to the 7th. All right, so this is our leading term. What's the degree of the polynomial? Well, the degree, of course, is the power of the leading term, right? Because that's the term with the highest power. So the degree of this polynomial is 7. Okay, because that's the highest power will be x to the 7th. All right, so now we're going to use that leading term in order to determine the long run behavior of this function. Long run, this should be hyphenated, shouldn't it? All right, so let's look at the limit as x goes to infinity of f of x. All right, and all I need to do to figure out that long run behavior is just look at the leading term. So I'm taking positive x values, I'm raising them to the 7th power, so they're still positive, but then I'm multiplying by negative 8. So they're just going to get bigger and bigger and bigger in the negative direction. So this is going to be negative infinity, right? Because we're taking a positive, x to the 7th will be positive, and then times a negative 8, so negative infinity. All right, so that's the long run behavior. And then the limit as x goes to negative infinity, again, we're going to take negative values of x that are going more and more and more negative. We're taking them to the 7th power, right? So a negative to an odd power is going to be negative, but then we're multiplying times a negative 8. So negative times negative is positive. So these are going to get bigger and bigger in the positive direction. So the long run behavior as x goes to minus infinity is positive infinity. All right, and that's how we can describe the long run behavior using limit notation. All right, well, we'll meet you in the next video for the next example.